Are you all see my slide? Yeah. So.
Yes, we can.
Okay, great. Thank you very much for the introduction and for the great program. I mean, this DSM bootcamp. It would have been even more interesting if I was there in person. But I believe we can learn a lot from each other and also a bit more about natural language processing. So just to get started, what is natural language processing? Everyone, maybe most of you are already aware of or familiar with this term. The last speaker talked about how to query some large language models, which is an application built upon large language models, which is also talking about natural language processing. So NLP is a branch of artificial intelligence with the goal of understanding, interpreting, and manipulating human language of different forms. So it could be text, it could be speech, like what I'm saying now, or sign language for the deaf people. So these are kind of some form of language that is being communicated. And we could say that natural language processing has some aspects of computer science. For example, my background is in computer science, but you also have a lot of things coming from linguistics. So it's an intersection of computer science and linguistics. And you don't have like machine learning in between that tries to connect both of them. So because you want to analyze human language, which has been well studied by linguists, and then you, as a computer scientist, you want to add some algorithms to it to be able to understand this human language. Interestingly, we also have extended natural language processing to programming languages. So you could do, for example, training large language models on written code from GitHub. And then you could also generate and ask the language model to actually suggest some code completion for you. We have several applications of natural language processing from language translation. For example, you want to translate from English to Yoruba language or English to German, sentiment analysis, building chatbots, and online studies. These are kind of like different applications of natural language processing. So, but there's a current trend in natural language processing now, is because we have so many tasks, like I've just showed you a few. Is it possible to build a single model that can work on many tasks at the same time? For example, if you have a single model that can solve almost all the tasks that are text related, or a single model that can do many tasks that are speech related, this has a lot of advantages because you can focus on building better and more powerful representation model that can now be used for different tasks. And such model is what we call the large language model. So current state of the large language models, we have several large language models nowadays. If you have some information about NLP, this is what is currently trending. From the last December, we had what is called ChatGPT, and then we even have a newer version called GPT-4, which is like the fourth iteration of the GPT model. We have GPT-1, 2, 3, and 4, and GPT-4 is the most powerful model. So these have been trained largely on natural language and code. So you could ask very complicated queries like how to prevent COVID-19, and it gives you a list of suggestions on how to prevent COVID-19. And then this information you can access it and you see that most of the information are correct. Wear a mask, social distance, wash your hands regularly, and so on. But I'm particularly interested in how these language technologies are scaled to other languages, not only English. So what if you try the same query in Yoruba and said, Báwo ni actually did know COVID-19? You find out that the language model is not very confident in Yoruba, so it's not predicting the replies in Yoruba, but rather in English. But this is a phenomenon we call cross-lingual retrieval. You pass something in one language, it retrieves the answer in another language. However, if you ask it to translate it to let's say Yoruba, the translation is actually very bad. For example, you say take white feather to the horse, and the translation is incorrect and meaningless most of the time. So, which already shows you one of the problems of current language models, that they do not actually scale very well to multilingual NLP. So, but LLM's abilities also extend to math and code. So this is a very simple example. It's a math question from DSN AI. And the question is, Josh decides to try flipping a house. He buys a house for $80,000 and then puts in $50,000 in repairs. This increased the value of the house by 150%. How much profit did he make? This is like an example of word problem from a secondary school math. Uh, the good thing is that this kind of language models can actually solve this task quite easily these days. The interesting thing is that it actually breaks the problem, breaks the solution down for you so that you can see how it arrived at this answer. I would call this kind of approach what is called chain of thought, because it's telling you how it comes uh, about the answer to the problem. So this is a very popular, interesting approach in a way that you can use it to improve the quality of the of large language models that have been developed, where you force the model to come up with the thought process of coming about the answer. So, of course, you can try to ignore this chain of thought by saying, answer the question in a concise way. And then it's going to give you just the answer as $70,000. But chain of thought actually makes you to know where the language model is making a mistake. So you could also use it to generate code. For example, if you say write a code to generate Fibonacci sequence in Python, it's actually giving you a working code in Python. And if you try to run this actually works. Of course, maybe this doesn't solve all your programming problems, but it can help. Last week, I was discussing with a colleague at TCA, and I was saying that yeah, he has actually been using ChatGPT to help him with his code debugging instead of using Stack Overflow. I find that quite interesting. Another interesting thing I've seen now is that because the goal now is to build a very powerful model that can actually solve different tasks. And this is actually possible for most text classification tasks. So almost all the tasks for text processing can be casted into a closed time for language models. So if you want to do sentiment classification, I love this movie, you can cast it like, okay, I love this movie, and then you say the movie is what? And then the language model can say it's great or it's fantastic. You can use this for topic classification, for intent detection, for text pair classification, for name identity recognition, for even text generation tasks like summarization, translation, and it still works. Surprisingly, even for regression. So I think this is quite interesting that we could try to build a very powerful model and then use it for different tasks. But prior to transformers, what we do in NLP previously is actually what is called this classical natural language processing, which is based on statistical methods. Usually, you have a bunch of documents. For you to work, you cannot use a single model for different languages. So you have to use a model. So the model for each language is very different. So the model for English doesn't work for Spanish, doesn't work for Arabic. And then you also need some other features, handcrafted features, like part of speak tags. Sometimes you have to remove stop words. Sometimes you have to lematize the words so that you go to the root word of the word. So you ignore things like progressive verbs, you ignore all those ones. And then you come up with a lot of features. And all these features are handcrafted, which is very difficult. So, but what happened when deep learning came? starting from 2000s, actually 2003. What you can do is that you can learn this end to end, and then you can give a set of documents and you learn this end to end. Another thing you can do is that you could also learn an embedding, a kind of embedding model that knows that can give you a good representation of every word in your vocabulary. So if you have the movie is great, you can build a representation model like Waterbeck that gives you a good representation for what is great, what is a movie, what is cat, what is dog, and you can actually compute similarities between this word and them. So this is a better approach. Number one, it requires that training data similar to the classical and natural language processing. But the good thing here is that features are learned, so you don't have to do handcrafting and coming up with different features that are quite difficult. For example, if you want to do POS tagging, it's very, very difficult. So we tried to do that for Masakhane. One of the Masakhane projects, it took us over a year to do that. So that means this is very difficult. And deep learning actually helps to rescue us from this building models with handcrafted features. Another good thing with this deep learning approach is that it often leads to better accuracy. Interesting. We have tried to improve, we have improved a lot. Starting from 2018, actually when I even moved into NLP, the process is very different now. What we do is what is called self-supervised pre-training. And the idea is that you can train a model, a representation model on a large amount of text. An example is the BERT model. For example, you could train a BERT model to predict missing tokens. If you give it a sentence, the chicken lays an egg, you can give it some blank spaces and ask it to predict chicken and hen. And if you're able to train the model in this way, whether using some LSTM or transformer architecture, you will be able to build a very good representation model. This is quite interesting because you can now use label dataset to fine-tune this model. And this is a very interesting an interesting strategy because previously you needed a lot of data to train models, but starting from 2018, actually you do not need a lot of data to train a model. So even with 10 examples, 100 examples, you can fine-tune this representation model, even with an additional architecture and solve different tasks, from sentiment classification to question answering, and so on. So this is more data efficient. And this is one attractive thing about pre-trained language models. So nowadays we have several pre-trained language models. So we have three branches of pre-trained language models. The red one, okay, one thing I have to say is that all these pre-trained language models are based on the transformer architecture. So this is a kind of model that was developed. So in deep learning, we have different kind of models. You could have something like convolutional neural networks, recurrent neural networks. Another one is the transformer architecture. And this is just based on attention. So the title of the paper is Attention is All You Need. If you don't have so much details about transformer, for now, just believe that there's a model called transformer architecture that has the encoder side and has a decoder side. So the encoder side, you try to encode information in the text, and the decoder side, you can see it as trying to predict something from what it understands. What you have tried to compose together, then it's trying to predict it. So this was initially developed for machine translation. The idea is that you encode information in a German language into a small vector representation, and then you can now decode it from this small vector representation to decode what is the translation in English. And that's how we have this encoder-decoder model. And this is only using attentions. And based on this information, we have the encoder-only model. They actually just use the encoder part of the transformer architecture. We have the decoder-only model that only uses the decoder side of the architecture. And then we have the encoder-decoder model that uses both. The encoder-only model started with the most popular one is BERT model, which was an extension of the Elmo model. And then we have the decoder-only model like GPT-1, GPT-2, GPT-3, GPT-4. They are examples of the only decoder model. So if you want to train a generative model, you often use just the decoder-only model. And for encoder-decoder model, you have also a class of model that uses both, like the T5 model proposed by Google. And it's a very powerful model because you can use it for so many tasks. For example, machine translation, summarization, and so on. Okay, so this is what we do, but starting from, I think, 2020, we have another approach. What we do previously is what is called pre-train and fine-tune your model. So you pre-train it on a large amount of unlabeled text that you find on the web. For example, you could take the entire Wikipedia, English Wikipedia article, and then use it to pre-train a BERT model. And then you can now fine-tune this model on a downstream task. For example, sentiment classification. The alternative, what we do now, is what is called pre-train, prompt, and predict. And a very good example is that you could prompt a large language model like ChatGPT to say, can you provide me what is the proper sentiment for this movie? So you can write a prompt. And this was trained also using self-supervised pre-training or just next word prediction. This is based on what is called causal language model. And what you can do, instead of fine-tuning this model on a small amount of data sets, sometimes you can prompt it with or without examples. And the language model is able to respond very well to you. However, for you to predict what will be the right answer, you need a verbalizer that tries to convert what is the output of the language model into what you actually expect in terms of the prediction. So the language model mathematically is just a model to estimate what is the probability distribution of a test corpus, or what is the probability of a next token given the context. So given a probability, given a sequence of words x1 to xt, you can compute with probability of x as the product of its conditional. So if you are familiar with the probability distribution, this should not be too difficult, but if you're unfamiliar, it's also fine. But the idea is that given previous words, you can predict what will be the next word. And this is what language models are doing, right? You give it a context and it's trying to predict based on what's to understand from the previous context. And then you can try to learn what is this probability distribution using the transformer architecture. One question, one of my most respected researchers in NLP is Graham Ubik, and he asked a question: how large is large language model? How many parameters does a language model has for you to call it a large language model? Of course, you can say if it has 100 million parameters, is a large language model, or 1 billion parameter is a large language model. For me, maybe 1 billion is large, but most people think like if you have like 10 billion parameters, is a large language model. And that is one thing you have to know, that most of this ChatGPT and all these large language models, you cannot fine tune them because they're just too big. And the other thing you can do is to prompt them. So we need to learn a new skill of how to prompt this language model to get good results instead of fine-tuning them. So what are the steps to build a very powerful language model? Now, number one is that you need a lot of text on the web. If you can crawl all the web data on the web and train this large language model that I've described, try to compute what's the probability of the next word given the context. Then you can create a powerful model as GPT-3. But for you to have an impressive model like ChatGPT, there's a lot of other processes that needs to go into it. One thing is that you might need to try to extend this to code, because you might benefit from some of the logical reasoning that are embedded in writing codes. And what they did is that you can fine-tune ChatGPT, you can fine-tune a GPT-3 model on code, and this gives you a model like Codex. Another thing that can be helpful is to make this GPT model to follow instruction. So this model has been trained on a lot of text, but the way they answer a question doesn't align very well with humans. And the one way to force them to align with humans is to force them to follow instruction. And that's how we come about what is called instruct GPT. So if you have a lot of annotated data and said, okay, if you have this kind of prediction, this is right, this is wrong, this is more human-like than the other, then the model is able to follow this more than what the probability distribution is just telling it, that this is the next topic. And of course, you can improve this by training a reward model based on reinforcement learning. And like that, you can create like a very powerful model like ChatGPT. Of course, there's a lot of engineering that goes into this that are not trivial. So, but there are some current challenges of this kind of model. Some of the challenges are what is called multilinguality. And one issue with multilinguality is that this model doesn't support many languages. For example, if you ask a simple query, I said, is this piece of news a business, entertainment, health, politics, religion, sport, or technology, and you ask it to predict this for Lingala, a language spoken in the DRC, Democratic Republic of Congo, it's going to tell you, sorry, I don't understand this, because you're asking me this question in a language that is different from English. So this is one issue we have currently with these models. Another thing is reliability and factuality of these large language models. So if you ask who is the CEO of Twitter, it's going to tell you based on my last update, which is September 2021. So it doesn't know what is the current information. And so that means you cannot always trust this model to give you the right prediction, despite how powerful this model is. So another issue is that there's an hardware constraint of fine-tuning this model. They're just so big, and you cannot even download the checkpoint. So I had some discussion with a few students, like was the last week, and they said we want to fine-tune GPT-3. I would say this is not possible. It's not possible to fine-tune this model because it's just too big. This contains more than 75 billion parameters. That means on your disk space, you need more than a terabyte to store this model before you can even run it. So other issues are there's broken evaluation. For example, the evaluation we're currently running are broken because maybe GPT-4 may have been trained on some of our test sets. We have some privacy issues. GPT-4 may have been trained on some copyrighted materials, on some user-sensitive materials, including health records, personally identifiable information. We also have some tokenization issues. They do not properly tokenize data by low-resource languages, and it makes it more costly to use this platform, especially if you're paying for it when you're querying with a low-resource language. The last thing is closed language model. Most of these models are closed, they're not open source, so we don't know what's going to this model. We can only access it through APIs. And actually, this limits the kind of research we can do using these models. Okay, so now I want to try to see if I can provide a simple example that shows you how you can go from data creation to building a very good model for African languages. Before that, I want to tell you that most NLP research actually do not focus on many African languages. Like I said, not all languages are treated equal by researchers. So if you look at most of the languages that have been studied in our field, many of them are focused on English language, a few European languages, maybe a few Asian languages like Chinese, Japanese, Arabic. But if you look at the distribution of the world languages, over 2,000 languages are spoken in Asia and in Africa. And these regions are underrepresented in terms of research in NLP. And then we try to see how we can address it. One key thing for NLP, even though we are able to build a very powerful model, is that there are still some challenges. And one of the challenges is that we do not have labeled data sets that we can use to train this model or evaluate these models. And one thing we have proposed is to use what is called participatory research approach. Basically, we try to involve the stakeholders that are interested in this data and evaluation experts to come together to build data set that can be used to evaluate African languages. The second problem is that we are not even able to build a very powerful language models or encoder models because we do not have enough text on the internet. And one way to address this is to adapt this model, adapt existing models to African languages using some very simple techniques that are very, very effective. For the first problem, I've told you we do lack data set. And if you could look at African languages, we have so many languages in Africa and so many language families, from Afro-Asiatic to Nilo-Saharan to Niger-Congo family, Khoisan, and Indo-European Austronesian. But in terms of research, in terms of the number of languages, find out that we have over 2,000 languages, and they are underrepresented in research. So how do we address this problem? So today I'm going to give you an example of how we develop data sets for these African languages, and just by using what is called participatory research, and now we also develop very effective models to adapt existing models to African language. So this is based on our Africa NLP workshop paper, news topic classification data set for African languages. So I'm trying to use a very, very simple task so that it's very easy for everyone to understand. The task of news topic classification is a sequence classification task. So if you have a piece of news in Nigerian PG, 5 things to know about Nigeria new Naira notes design. How can you categorize this news? This can be seen as a business news because it's talking about currency, money. If someone gives you another news headline, John Boyega don't win GQ Icon Award for the second time, this is an example of an entertainment news. And then you can have something about AstraZeneca vaccine, and this is about health, and something about UEFA apologized to Liverpool, and this is about sports. This is a very good example of an NLP task. The question is that how can we build a very good model that can do this for African languages? So I want to first tell you that prior to 2019, we do not even have enough data sets for African languages that we can use. And in 2023, through many efforts of many African researchers and also through Masakhane community, we have been able to develop many data sets. We have different initiatives like Zindi ever competitions, where they encourage people to release data set for competition, Africa NLP workshop, and some of the outputs of these workshops that people release new data sets. For example, even DSN has have consistently contributed into creating new data set for African languages by submitting some of their papers to African NLP workshop. And MasakhaNEWS is an organization, a grassroots movement that tries to encourage people to come together to actually work on this problem together. We also have some funding initiatives like AI for the Lacuna Fund that are trying to address some of this problem. So Masakhane is a grassroots NLP community for Africans and by Africans pioneering participatory research for African NLP. And Masakhane organizes African NLP workshop at top AI conferences. We have over 2,000 members of Slack. It's an open platform if you're interested to join. And the initial goal of Masakhane is to build machine translation models for African languages. But we came together to say that, okay, we can address this lack of data problem because we are the speakers of this language. Is our language if we can develop data sets for this language. So my short outline for MasakhaNEWS is first I'm going to talk about how we develop data sets and talk about some of the baseline experiments and some zero-shot or few-shot experiments. So why do we need to create this new data set? To be honest, we do have some previously annotated data sets. One example is that there was Hausa, VOA, and Yoruba BBC data sets, which I was part of that we created in 2020. But this doesn't use the entire news article. It only uses the headline to classify news articles into maybe business news, entertainment news, sport news, and so on. We have what is called key news and key news that was developed, but the problem is that they have different label configuration. So you can have many languages and the label of this is different from the other, and we wanted to address this. We also have some news topic classification data set that were automatically created, but we cannot trust them. Also because some of them also have very different label configuration. So our contribution is trying to address this by creating a new topic classification data set for 16 African languages. Also, we provide an evaluation of baseline models using classical machine learning and fine-tuning of language models. We also provide some alternatives to full fine-tuning because we don't want to fine-tune the model because it's very expensive, like prompting ChatGPT or cross-lingual parameter efficient fine-tuning and so on. But because of time, I won't go into everything, just a few. So the MasakhaNEWS project, like I said, we are coming together to address this problem. Different stakeholders, native speakers, evaluation experts, we came together to address this problem by creating data sets. We have most of our contributors are from Africa. You can also see Nigeria being represented. We have 15 from Europe, 8 from North America, and 1 from Asia. So this is the geographical or linguistic diversity of our new data set. Most of the languages we cover all the 4 major languages in Nigeria: Hausa, Yoruba, Igbo, and Nigerian Pidgin. We cover some languages in East Africa: Chigrinya, Amharic, Oromo, Somali, Luganda, Kiswahili, Rundi, and so on. And a few languages in southern part of Africa. And you find out that these languages also actually belong to different language families, like Afro-Asiatic, Amharic, Hausa, Niger-Congo families, and so on. So our data set was created using BBC article. I'm going to tell you how we created it. It's very simple. And this is just to encourage you that even if you're a native speaker of these languages and there's lack of data set for you to work on, you can create your own, be inspired to create your own. DSN has a very large community, and you have a lot of young people that can contribute to the sustenance of their languages. Even if your language is only spoken by 1 million people or 500,000 people, you can create new data set for your language. So from BBC article, we collected articles from 12 languages, and then also from Voice of America, because not all languages have news articles published by the BBC. And then you say this is a distribution. I think the largest number of articles was collected by This language is a cursor from South Africa, but most of the languages are around 5,000 articles, so between, let's say, 2,000 and 10,000 articles. This is how we collected data. You have like a BBC article like this. You can automatically extract some of the categories. For example, you can go to entertainment and arts, part of the news of BBC, or you can go to sport, business, politics, culture, or tech, or health news. And we collected some of these popular categories by BBC, and then we use it to do the annotation. We also added religion because many BBC news articles, especially I've checked for Yoruba news, and many of them have religious content, maybe some greeting about Easter, some greeting about Christmas, some greeting about some Muslim holidays are very prevalent. And we try to see if we can create like a label data set with at least like 3,000 sentences. So we recruited our annotators from native speakers from the Masakhane community. Each language had like minimum of 2 annotators, except for Luganda or Kirimbi, where we didn't have a lot of volunteers. Our annotation followed the step. First, because we wanted to speed up annotation, we make use of what is called active learning. First, we manually created like 200 examples of text, and we gave it to annotators to annotate for us. And after that, we trained a classifier, which is we trained a classifier to automatically label uh, this based on what other people have labeled. Okay, the way to think about it is that you ask everyone in this room to label 200 articles into business news, political news, sports news, entertainment news. And based on this, you train a classifier to annotate 3,000 examples. And followed by that, we now try to verify the annotation. Then we ask the volunteers to go over what was automatically annotated and try to verify it. And we use this tool, which was an internal tool that was developed at UCL. And an example is like this. Roger Federer go miss the rest of the 2020 tennis season. This now waiting we know. This is the headline. We provided more context from the article, and we asked people to annotate. Is this a sport news or business news? And people can also verify if this is true or not. Okay. For the final data set, we had like minimum of 4 topics that covers health news, political news, sport news, and we're quite successful for many languages, except for Lingala or Shishona, because they didn't have a lot of articles for some categories. So for Lingala, what we did is that where there was conflict between the annotators, we tried to resolve the conflict. And for Shishona, we tried to collect more sport news from a different website. Okay, and this is the data set we have created. For the models, what we did is that we developed, we evaluated using some classical machine learning methods like naive Bayes, simple multi-layer perceptron. An alternative is that we can fine-tune some pre-trained language models. And most of these pre-trained language models only support few African languages. In our case, we found out that they actually support like half of the languages we are interested in. So one way to try to adapt a language model to cover more languages is using a method which we have published in Calling, saying how do we adapt pre-trained language models to African languages, which also got the best paper award. So some of the challenges of adapting pre-trained language models to African languages are: number one, there's limited language coverage. And many languages are not covered when they pre-train these powerful encoder models. And this is due to non-availability of corpora that can be used and what we call cost of multilinguality. So languages that are seen during pre-training often have better performance than languages that are not seen during pre-training. A simple way to address this is what we call multilingual adaptive fine-tuning. That means you can take an existing model, you initialize the weight of this model, and you adapt it to many African languages at once. We are inspired by this by what was done by Meta AI for MBAT. The initial MBAT model was trained on 25 languages, and it was now extended to 50 languages. By continuing pre-training on the existing 25 languages and new 25 languages. But in our case, what we do is just to specialize this model to only African languages. So for us to do this, we started with a single encoder model that cover all the major African scripts that are used in Africa. Then we adapted it to 17 most resourced African languages and 3 high-resource languages. And by this, we were able to cover many regions of Africa and then our model now supports many regions of Africa. Our model is this, which you can find on Hugging Face, and you can fine-tune this on any task in NLP. And now we also provide some other versions of this model. We provided also model not to cover only 20 languages, but to cover 29 languages, even 61 languages. And currently we are working on a model to cover even 75 African languages. And we also have some more compute-friendly ones that if you don't have a lot of compute, or if you want to run models, NLP models on Google Colab, you can use these compute-friendly models. So this is our baseline results. If you compare the classical NLP methods to more deep learning approaches based on protein language models, you find out that, of course, for this task, even the very simple methods like naive Bayes actually have some quite good results, but it could be very low for some languages like Swahili. But if you use protein language models that are based on deep learning, you often achieve very impressive performance, like a huge jump in performance. And the interesting thing is that if you use African-centric protein models that have been adapted to African languages, the blue bar, you can even improve the performance significantly. Another thing we found is that for the classical MM methods, like naive Bayes, they require a lot of text for them to have very good performance. So you have to combine headline plus the entire news article for them to give you a very good performance. But for protein language models, you only need the headline. Even with the headline, you can have very impressive performance. For zero-shot setting, in the case of zero-shot, we assume that you do not have any label data. And one way to solve this is that you can prompt a ChatGPT to help you solve this problem. Or you could use some also multilingual embedding platforms like Cohere has a multilingual embedding API that you can use for text classification. So for you to prompt ChatGPT, language models have been trained to predict the next word given the context, but you can also prompt it for discriminative tasks. So this is an example of a data set. We have the category, we have the headline, we have the text. And then you can have a prompt like this. Is this piece of news regarding business, entertainment, health, politics, religion, sports, or technology? You can say, provide the headline and the text. And this is an example. Tinubu denied Torise I won contest for 2023 presidency. And then you provide the entire article and ChatGPT replies with, this is a piece of news regarding politics. With this, you have been able to solve the problem, even though it's not a generative task. That is the headline, that is the text, and this is the completion. Then the question is, how do you convert this completion to the category you're interested in? You need a verbalizer. So a verbalizer tries to convert every prediction into the actual category you're interested in. The prediction of ChatGPT can take different forms. Some can be short, like just sport. Some can be about this piece of news is regarding sport. Some can be longer, how do you try to get the right category? Then you can use a sample verbalizer that whenever it sees business, finance, economy, economics, it should assign it to business news. Whenever it sees like entertainment, music, it should assign it to entertainment. And with this, you can convert it to the right category. So I guess over time, maybe I can already pause here. I have 3 minutes more. Okay. All right. So I think this is another approach to improve over it, but I'm going to skip because of time. Let me just show you the evaluation. Maybe briefly, this is one way you can use the Multilingual Embedding API. You can provide few examples, just 2 examples for health, for politics, and sports, just two examples. And then you can give it new examples, just 2 per class. And this model, this embedding API, which you can find here, Cohere, playground, classify, and then you can classify this if you only provided just 2 examples. So this is an example of few shots learning example. And for the 0 shots, one thing you can see is that ChatGPT sometimes perform very poorly on some languages like Amharic or Tigrinya if they use another script. But GPT-4 actually is more robust and actually like achieve very impressive performance. So for the few shot setting, also we find a Cohere API. If you have very few examples, like 2 examples per class or 5 examples per class, it actually gives you better result than fine-tuning a pre-trained language model. So this is showing you that you can use this multilingual embedding layer API online to actually achieve very impressive performance. Also, the performance is also quite good for 10 shots, but once you have more examples, then the traditional methods are actually quite good enough. So in conclusion, I just like provide some introduction to NLP, and I also want to make it concrete by showing you how to develop dataset for African languages and how to build models using encoder-only models and also prompting ChatGPT. Thank you.
Very much, Dr. David Adelani. I believe we can do better than that for Dr. David Adelani. Those of us on the call, right, you can go ahead to drop your appreciation. We recognize you. So please go ahead, use the chat session, and I appreciate Dr. David Adelani for that session. All right, so we have a few minutes for questions. I don't know if there are any questions from those of us here. Any questions on what Dr. David Adelani has just shared with us? Okay, does it mean we understand everything? Or we need time to distill all of the things he has shared? Awesome. All right. Okay, so Doctor, everyone on the call and either virtually and here with us, the session will be shared with them. Of course, they need to go over it again, right, to like take in all of the insights that you have shared with us. Doctor, we sincerely appreciate your time with us, and on behalf of the management and staff of DSN, we want to say a very big thank you for being a part of this session today. Thank you very much, Doctor.
Okay, thank you.
Welcome. You have a great day, Doctor.